Okay, good morning. Last time we discussed Hamming code development for error detection. And today we are going to continue. Once we have that code, we want to decode it. Right? So the procedure for decoding. Before that, we briefly review what we discussed last time. We use the example to show this. So linear block code decoding, encoding, sorry. Right? And the BCC is a linear combination of the data. So that is the basic idea. And one simple example is the first part of the code is only the data. Then the second part of the code will be linear combinations of the data. And in that way, we are going to write C1 as D1, and C2 equals D2, and so on. CK equals DK. And then we are going to have CK plus 1 equals any linear combination of the data. And we have all the way to Cn equals like this. And H11 and D1 plus and so on. And M1 D1 plus. And for easy calculation, and we write this one in the matrix form. The matrix form will be the code equals the data times a generated matrix. And the generated matrix is in this form, is 1, 0, 0. We use our example to show this. In the example, the generated matrix equals we discussed the general first. So this one will be equals like here 1, 0, 0 and 0, 1 and all the way to 0, 1 here. So this part is an identity, just all ones on the diagonal and zeros on off diagonal. And this part is H11, H21, and HM1, and H2, H1, 2, and H2, 2, and HM2, and the last line is H1K, and H2K, and HM2. And we call this part as a identity, and we call this submatrix as a matrix P. We just denote it like this, because later time we are going to use this. And this dimension of the P is K lines, K rows, and M columns. So that's K by M. The example is the generation matrix equals 1, 0, 0, 0, 1, 0, 0, 0, 1. So that is the first part identity. And the second part is 1, 0, 1, and 0, 1, 1, and the last one is 1, 1, 0. We can interpret this with this idea. That means the first code equals the first data, the second code equals the second data, and the third code is the third data, and the fourth one equals the data 1 plus data 3. Right? And the next code is data 2 plus data 4 plus data 5, data 2 plus data 3, and the last code equals data 1 plus data 2. Right? I hope you still remember, if I give you a data, you can generate this code, right? So for example, the code, if the code is, if the data is 101, and you plug this data equals 101, then multiply by this matrix, and we get the code is we did this last time, the code will be equals 101, 101, and 011. So for this data, we get this code. That's a review from what we discussed last time. Okay, today we are going to discuss linear block code decoding. The idea is we received something at the receiver. So how do I know what data it is at the transmitter? Even better, if there's an error, we can automatically change the error. Right? So that is the idea for decoding. First, I discuss the procedure for decoding. The decoding is we have received the code. At the receiver, we receive the code. The received code is the transmitted code. We can see the received word, or no matter what you have, we just use R to represent this, means received. The received equals the transmitted, the correct one, the transmitted code, then plus any error that will occur in the transmission. For example, if you transmit equals 101, you want to transmit, for example, this one, 101,011. If you want, okay, let's make this first one easier. If you want to transmit this, C equals 1, but your error is 1, then what will be received? Our received will be equals C plus E is equal to 0. Right? You want to transmit 1, but there is one error, and the error is 1, so your received actually is 1 plus 1 equals 0. If your transmitted equals 0, but the error equals 1, that means your received will be still C plus E equals 1. And you transmit 0, but there's an error, and you received 1. So this is only a single digit. In this example here, suppose the correct code is 101,011. But we have error here. The E equals, for example, if there's an error here. Let me see where the error is. Suppose the error is like this one. This is the error. So the error is here. If the error equals 1, that means there is an error. If the error equals 0, that means there's no error. Right? So the error is here, and the error, this one here is nothing, 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 nothing. That means we have only one bit of error occurred on the third digit. So the error will be 0, 0, 1, 0, 0, 0. The correct code is this. The transmitted error is this. That means we know the third digit is wrong. Then what we receive? The received is this one plus this one. So it will be 100,011. Does it make sense to everybody? These are the errors during the transmission. This one is the correct code here we want to transmit. This meaning here means there is only one bit of error occurred on the 1, 2, 3, the third digit. That means this one is wrong. So that means 1 plus this one will be equal to 0. This is supposed to be 1, but we received 0. So this is the R. Okay? Now the R equals C plus E. We use modular 2, so that is not just the add 1 plus 1 must be equal to 0. So this means if we know the error, if we know this E, that is what we want, because this one we know this is received. If we can determine the E, we want to find C. So C will be equal to R plus E. Is this correct? C will be equal to R plus E.
Yeah.
It's supposed to be C equals R minus E, right? Because we know in binary plus minus is the same thing. So that's once we find the error, we determine from the decoding process. Once we find the error, this one is what we receive. So we just add to the error, then that is the correct code. That means we finished the decoding. That's the procedure. Right? So we can see here, that is what we want. Once we find the error, then everything is done. We just add this error to the received, then that's all. Right? That is our purpose. Now, step 1 is we need to find a quantity. It's called syndrome. we use S to represent this. We know R, right? That is what we received. And we know the generated matrix. This is G here, right? Because this generated matrix must be known to both the transmitter and the receiver. So we know this. So the S will be equals defined by the the R, which is the received, times a matrix H, then transpose. Okay, now we need to ask what is H? H is this. We know this G here, and this part is identity, this one is P. So we are going to write P first, and the identity second. Like this one. That is the matrix T. We need to transpose this here also. Right? Does it make sense? We know the matrix transpose all these operations, right? Transpose means if you have the matrix 1, 2, 3, 4, 5, 6, what is this transpose? And the transpose equals 1, 2, 3, 4, 5, 6. We change all the rows into columns, change all the columns into rows. So the first row, we are changing to the first column. The second row, we are changing to the second column. So this is called transpose. Right? If we know the generated matrix, we know G. The first part is identity, the second part is this, and we call this as P. Then once we know P, we can find the P transpose, and which we will put here. That means this one, the first column will be equals to H1, 1, H2, 1 like this. And this one will be the second column of here. This one will be the last column here. Then followed by the identity, always on the diagonal. Make sense? These are the theories. Later time we are going to use example to show step by step how to do this. Alright? This, but now this one is H. This is H. This is HT. So we need to transpose of this again. So HT will be equals okay, that is P on the top, then I is on the bottom. From generated matrix, we can generate HT. Then we can calculate the syndrome S. So that's the step one. Any questions on this? Once you have to receive the code, the receive, you can calculate the syndrome S. Any question on that? You just multiply with this, with the HT, which is this P here on the top and I on the bottom. P is given here. And you put all I's on the I's on the bottom. Okay? So that's the first one. Okay, next we are going to this. This is the step one, necessary. And step two is we are going to use some theory that we won't prove, which is correct. For every code, this one must be true. CT transpose must be equal to 0. We just take this one for granted, and we do not prove this. So C times the code, the correct code, multiply H to the T, transpose must be equal to 0. Okay. Now let's see what it is. The code, so the S will be equal to, here, R, right? R equals C plus E, so C plus E, this, then times HT, HT is here, right? And this one will be equals C times HT plus E times HT. And we know that from theory, C, HT must be equal to 0. So this one must be equal to 0. Then we have only this left. So this one will be equal to E times HT. We know the S, we know the syndrome, right? We calculate from step 1. And HT, also we know this. So the only thing we don't know is the E. So we solve these equations. They are set of equations. Once we solve the E, then step 1 is the correct code will be equals the received plus E. Right? That's all. Questions on that? So this, we derive the steps how to. I give you a code, you receive a code. There's some error inside. you calculate the error first, by calculating the S first, then solve equations, find the error, then you add the error to the received, you get the correct code. That's the whole process. It's called the decoding. Right? Next, we are going to example. We take this as an example. Suppose the correct data is 101. Right? And from last time, we know the correct code must be 101.011. 101.011 with this generated matrix. Everyone needs to know how to do this. But we assume there's error. So the received, but the received R equals, I put some gap here, the R equals 100.011. That is what we receive. And now forget about this, because we don't know this. We don't know what we transmitted, which one is wrong. We just receive this one. That's the only thing we know. And also the generated matrix. We know only two things. The first one is the received, maybe correct, maybe incorrect. We don't know. And then the generated matrix. And we need to find out the error, then add the error to this, and hopefully we can determine the correct code is this. That means the data is this. That is the purpose. Is this clear to everybody? Okay, then what's the step one? How to do this? Steps are here, right? Step one is to calculate the syndrome S, right? Okay, so S equals, what is S? The formula first. Equals R, because we know this, right? That is the received. So we know this. We know this. Right? So S equals R times HT. Right? So times HT. So that will be equals 100.011 times HT. Now you need to be able to write out HT. HT is P on the top, I on the bottom. Where is the P? P is here, right? This is P. So that means in the generated matrix G, this part is P. Does it make sense? Right? This generated matrix will be in the form of the first part is identity, the second part is called P. And P is here. This is identity here, then this part is P in this example. Right? So P equals, we need to write P on the top. So what's that? 101, 101, and 011. What's next? What's next? 110. Then what's next? The I on the bottom, right? Make sense? The I on the bottom. So I means the identity matrix. So it must be 100.011. Sorry. 001. Like this. So that is called HT. P on the top, identity on the bottom. Okay? So we know this, we receive this, I'll give you this, and you know this, both the transmitter and the receiver know this from the generated matrix. So now we can start to calculate this one. Alright, so what is this? This, alright, so this, the dimension of this is 1 by 6, right? 1 row, 6 columns. This one is 6 by 3, so 6 by 3. Then the result will be 1 by 3. That means we have only 1 row and 3 columns. So that will be the result. Right? The first one is this first. Okay, this is 1, 1. That means the first row, first column. So this time this, 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 this time this. Okay, then multiply, then add. And the second one is this time this. That means 1 times this, 0 times this, 0, 0, 0. Okay, 1, 1. Then you add again. And the last one, same thing. But last time we mentioned give you a tip, right? Here, that means this one multiply from the left. That means actually this one is just the first row, add the 5th row and the last row. So what we do is this one and this one, these 3 rows add up together. If you don't want to memorize this, you don't like this, you just start from the definition. Right? multiply, add, then you get the same thing. Right? This one is easier. So this plus this plus this. So now can you tell me what's the result? This row plus this row plus this row is this row. 1, right? The first one is 1. The second one is 1, right?
Yeah.
Because 0, 1, 0 here. So 1. What's the last one?
0.
0, 1, 0, 1. So 1 plus 1 equals 0.
Yeah.
That's the result. Questions? It's good? Alright, so that is the syndrome we done the first step. Then the second step is to solve this equation. S equals E times T. And we try to solve E. Once we solve the E, then the last step is just add E to the receiver, then that's it. Huh? Looks pretty simple.
How do you get E?
Alright, E, we need to solve this equation. S equals E times T. S equals E times T transpose. Alright? And we know S, right?
Yeah,
Do we know S? S is here. Right? Now, we don't know E. Okay, we are going to write E as E1, E2, E3, E4, E5, E6, because I don't know which one is wrong. If all this equal to 0, that means there's no error. If this one equals 1, means there's an error occurred in the first digit. If error is here, that means this one is conceived. So we just try to solve this E. Then this one multiply by, so I think I can just write this. So this one multiply by HT. Where is HT? Is this HT? Yes, right? This is HT, right? So this part is HT, so you need to write it here. So we don't need to write. You can copy here, but I just, too lazy, I just use this one. Does that make sense? So now let's see what is the result. Instead of this times this, now we use this one times this. Can you still apply the trick we mentioned? So this times this matrix, the result will be, we have 3, right? Just like this here. Because this one, see, here, multiply this, we get this. Now, it's this, multiply the same thing.
1 by 3.
So we are going to have 3 numbers on the same row. So what's the first one? We said S equals this times HT, then equals like this. How we get this one? How do we get this one?
Oh, no.
We use the first row, second row, this plus this. So that means this one plus this one plus this one, right? But now look at this. So this one here, now this one you need to apply from the right. From left, apply to the columns. And from right, you need to apply to the rows. So look at this one. So this E times this times this. Here, times this one. What do we get?
1.
E1, right? E1 is here. E2 is gone. Yes?
Yeah.
E3 is here. E4 is here. 5, 6 are gone.
Yeah.
So that means the first one is E1 plus
E3 plus E.
3 and 4, right?
Yeah.
Okay, E3 plus E4. So that is the first result. How's the second one?
E2, 3, and 5.
Yes, 2, 3, and 5. So E2 plus E3 and E5. What's the last one? Here, this side. Hello? This side. Anyone tell me what's this one?
Oh, third one is E1, E2, and E6.
Yes. E1, E2, and E6. So E1 plus E2 plus E6. So that is E multiplied by HT. What is this? This must be equals to S, right? So what is S? S is 1, 1, 0. So this one will be equals to 1, 1, 0. Question on that? So what does that mean? That means
so
this one equals 1, this equals 1, this equals 0.
Hey, so that means that if any other code come through, that it will not. If any code on the third line.
The third line. What do you mean third line?
On the E1, E2, and E6, if any one of those ones change.
E1, E2, E6.
Yeah.
Yeah.
If you get another code come through, it's not.
What do you mean another code? We don't have a code. We don't know the code. We only have the receive. That's the only thing we have. This is what we receive. We don't have any code. We try to find the code. Huh?
It's 5 degrees.
Alright, so now we have how many equations we have? 3. Okay? This equals 1, this equals 1, this one equals 0. We have 3 equations. We have how many unknowns?
How many what?
Unknowns. That means we want to solve. How many variables? We don't know E1, right? We don't know E2, we don't know E3. So we have all 6 unknowns. 1, 2, 3, 4, 5, 6. So we have only 3 equations, but we need to solve 6 unknowns. Okay? Theoretically, we are going to have 8 solutions. So we solve this E. Okay, let me write out. So E1 plus E3 plus E4 equals 1, and E2, right? For easier, I write this. So E1 plus E3 plus E4, and this one will be equal to 1. And the second one is E2 plus E3 plus E5 and equals 1. Okay, the next one will be E1 plus E2 plus E6 equal to 0. So we are going to solve these 3 equations at once for 6 unknowns, E1, E2, E3, E4, E5, and E6. We are going to have 8 set of solutions. Now we need to determine only one. So which one we are going to solve? We choose the rule is we said we have 8 solutions here. We are going to choose the one with minimum weight. What does it mean minimum weight? Okay, that is the number of ones is called the weight of the code. For example, this code. How heavy is this code? What is the weight of this code? The number of ones in the code. What is it? 2. Right? How heavy is this? What's the of this code? 3. Right? You just count the number of ones. That's it. We have 8 possible solutions here. We are going to choose the one that has the minimum weight. That we will consider that one as our solution. That is our E. Once we find the E, we add to the received, then problem solved. Questions on that?
They all got the same.
We haven't solved the equation yet. I'll just tell you the ideas what we are going to do, because we know there are 8 solutions here. There are a lot. But we are going to choose only the one that is the lightest. That means the number of ones is the smallest. The best way is the best one is all zeros, right? Make sense? The best solution is all zeros, if it is a real solution. Because if the solution is 0, 0, 0, 0, 0, 0, then the weight is 0. So that's definitely the minimum weight. But now let's ask, is this one a solution here? That means E1 equals 0, E2 equals 0, E3 equals 0, E4, E5 equals 6. All the errors are equal to 0. That means no error at all. Is this a solution over here? No. Right? See? 0, 0, 0, you cannot get 1. 0, 0, 0, you cannot get 1. So this one is not a solution. So this one, no. Okay, what's the next possible solution? Because this one, weight equals 0, there's only one possibility, right? Just all zeros. Then the next one will be the weight. This weight equal to 0, right? The next one will be the width equals 1. Okay, that is the next minimum. Now in this case, we are going to have 6 possibilities. Because the number of ones, the only ones in the code. So it's possibly like this. Right? So the solution possibly like this one. This one has a width of 1. Or the solution may be like this. Or maybe, right, the last one is 0, 0, 0, 0, 0, 1. But anyway, we are going to have 6 possibilities. All these possible solutions has width of 1. So those are the next candidate, the minimum, because 0 won't work. Does it make sense? Now the question is, which one is correct? So we need to find out. Alright. Suppose we try this one. We assume E1 equals to 0, all others equal to, E1 equals 1, all others equal to 0. Is this a solution? No. E1 equals 1, all others equal to 0. That's one good, right?
Yeah.
Alright, this one, no E1, all this 0,
No.
this one is not good.
No.
Okay, so this one is not a solution. Alright, now you try, how about the second one? Only E2 equals 1. This one is not good, right?
No.
Okay. Okay, that's done. Okay, now next one, E3.
Yep.
This one is good. This one is 0, this one is 0. Okay, E3 is good.
Yep.
Nothing, nothing, nothing. Okay, this one is good. Looks like the solution is, at least the one possible is 0, 0, 1, 0, 0, 0. So this one is a possible solution. And this width is 1. Is the next minimum to this, but this one does not work. Okay, now let's try 4. E4 equals to 1 only.
No.
This one, good. This one, no. Okay, so 4. How about E5?
No.
This one, no. Okay, how about E6?
No.
Oh, no. This one. Okay, so the code, the possible solution that actually is not possible because it is a solution. The solution with the width of only 1, there's only one candidate, so that is this one. Definitely we can try more, right? The width equals 2, that means, okay, we try 1, 1 equals 0, then we are going to have like how many? Okay, 15 trials. But do we need to do that? Do we need to try, okay, E1 equals 1, E2 equals 1, all others equals 0, check if they are solution or not. Do we need to do that? No, because our rule said we only choose the minimum width. So if you said this one, the width already equals 2. Even it is a solution, we don't choose it because we choose this one. So that's it. Alright. So the solution will be E will be equal to 1, 0, 0, 1, 0, 0, 0. That's all. Alright. What's the next step? We know the error, right? So we already determined the error is 1. What does that mean? Where is the error? On the third digit, right? There's no error here, there's no error here, and the error is here. No errors in 4, 5, and 6. By this, you know which one is wrong. This is the received. And this one is the received. So we said the third digit is wrong. This one is wrong. That is our conclusion. So next one is the correct code equal to, what is the code? The formula is what? Received plus E. E is this, received is that. Right? So just E is here, and the received R is I copy here, so 1, 0, 0, 1, 0, 0, and 0, 1, 1. Right? We add these two together. So what is it? 1, 0, 1, 0, 1, 1. So that is our code. Any questions on that? Is everything clear? Somebody say yes, 100%, right? 80%?
60.
60%. So which part is not clear? Now you close your eyes. You think about this question. First one, what we are doing here? That's how we study, right? So what is the problem? Anyone can tell us what is the problem? What we are doing today?
You decode it. I mean,
You receive a code, right? You receive something 6 digits.
you try-
We want to know which one is wrong.
Yeah.
And once we know that the one is wrong, okay, in this example, we know the third digit is wrong. So we just change it, then we get the correct code. From here, the correct code is here. Now look at our book, okay, dictionary. So the data will be equal to, from the last time, we know the code and the data. So from here, we know the data equals to 101. We introduce the additional checking bit. All this, the benefit is we know this is the correct data is 101. And we can automatically correct this, even we have some error here. So we said the problem is, I give you a 6-digit code, received word or something. We need to find out if there's an error, or if once we know where the error is, we want to change it. That's easy, right? Okay, so that is the purpose. Then how are you going to do it? Step 1. Right? You don't look at this. You just imagine in your head, because we already know this. So the first step, what are you going to do?
Find the minimum weight.
Find the minimum weight. That is the last part, right? Okay, so what's the first step? I'll give you an R.
First step is to find X.
Yes, the first step is to find the X, right? Yes or no? How to find the S? S equals what?
RHT.
R times HT. Okay, R we know that you are giving.
Yeah.
Okay, now the HT. Where is the HT?
Is P of I.
HT is in the generated matrix.
Yeah.
HT is P on the top, I on the bottom. In the generated matrix, G is P on the second, on the right, I is on the left. But you need to move that block on the top, then put I, just switch the position, right?
Yeah.
So that is HT, so we know that, right?
Yeah.
So you calculate R times HT, you are going to get a syndrome S. So that's the step 1. What's next?
Find the weight, the lowest weight.
The next one is we need to find the error, right? Or we need to list the equations that we need to solve.
To find the error.
The equation is given by the syndrome equals E times H transpose. Yes?
Times.
Syndrome with S, we already know that, right? So the syndrome will equal to the error multiplied by H transpose.
Yeah.
Okay, we know H transpose. We don't know E. E is represented by E1, E2, E3, E4, E5, E6. So you write this one. Okay, in this example, we have only 3 equations. But we need to solve 6 unknowns. E1, E2, E3, E4, E5. So basically we are going to have, so the difference is 3, right? 6 minus 3, so equals 3. So we have possibly 2 to the 3, which equals 8. We have 8 possible solutions. And in the slide, we list all the possible solutions, but that's not necessary, right? And you can try by yourself how to find all these solutions. But again, the reason is because we need only find the solution that has the minimum weight. So that's give us a trick. First time you try all zeros.
No.
If that's satisfied, then that means if the E equals all zeros, if this one is good, satisfy this equation. What does that mean?
I got a question.
Yes.
What if it be more than one solution? Is it ever
There are
more
8
than-
solutions.
No, I'm saying like for this though.
There are
More than one that work. How about that?
for this one,
Yeah.
it won't.
It'll never be more than one that
It
work.
won't.
Okay.
Otherwise, you cannot. That means your code is not your design. You must have some errors in this one, because we need to able to determine one bit of error.
That's it.
If you said, okay, the error is like this, or maybe possibly like this. Okay, so one is here. Then I give you this one. You mean okay, I need to change this one, or I can change this one. Can you decide? You cannot. That means your code design must be wrong. That means this code, if you have a solution like this, that means this code does not have the error correction capability. You cannot do that because you don't know which one to choose. If your code designed correctly, you must have only one solution, the minimum. And later time we are going to decide why this one is not possible. That means while the capability for error correction is only 1. Later time we are going to discuss. All right? We're supposed to discuss last time, but we can still do this. So we try all zeros. Okay. In this example, no solution. All zeros are not solution. Suppose if all zeros is a solution, what does that mean?
There's no error.
There's no error at all. You just the code received plus 0 still equals self. That means your received is correct. No error. That is possible, right? But in this example, it's not correct. The next one you are going to try the weight equals 1 because the next minimum is 1. In this case, we have 6 possibilities. The 1 is on the first one, the 1 is on the second one, the 1 is on the third, fourth, fifth, sixth. So you just try, this one easy to solve. So, okay, in this example, we said the 1 must be on the third one. Right? That is the solution. Then we are done. You don't need to try the second or third one. And in the slide, you can see the maximum error can be 1, 2, 3, 4, 5. Right? Okay, I just so the error can be 1, 1, 1, 1, 1, 0. This can be the error. That means the first one is wrong, the second one is wrong, the third, the fourth, the fifth. All these 5 are wrong. Only the last one is correct. Well, let's check. Is this a solution for here? U1 plus E3 plus E4 equal to 1. Is it good? This one plus this equals 1. It's good? Okay, so that is good. How about the 2, 3, 5? 2, 3, 5. Add up together equals 1. Yeah, okay, so let's satisfy this one. How about the 1, 2 plus 6? 1, 2 plus 6. Is this one equal 0?
Yeah.
Yes. Right? 1, 2, and 6. 1, 2, and 6. So add up together equals 0. That means this one is a solution of this. That means I can see this one is wrong, this one is wrong, this. All are wrong, only the last one is correct. If you decide this is the real case, then the correct must be a 0, 1, 1, 1, 0, 1. This one must be the correct. Does that make sense? So we are going to have 8 possible solutions, but which one is the correct? We use this one, the minimum. Right? Because this one, again, possible, but you are going to try to correct how many errors? 5. That is beyond the capability of this code. We cannot do that because we have a multiple. You cannot decide by this. This is not the unique solution. The only unique is only 1. Feel better? 60% to
75.
75. Okay, you still have like 25, right? Now let's answer your question. Why this one? There's only one solution. There's no way you can have another one error. Right?
25 degrees.
Remember last time we used this one, right? The code equals the data times G. G is this, G is here. The data is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. We have 8 possible data, right? All those data put here, multiply by this, and I will write the, can you read all this? Okay, I erase it. All this data, D is 8 by 3, right? So this data will be 8 by 3 here. 8 by 3. And this one will be 3 by 6. 3 by 6. So the result will be 8 by 6. Now I just copy from last time. The C code will be 0, 0, 0, and all zeros. And 0, 0, 1, 1, 1, 0. And 0, 1, 0, 0, 1, 1, and 0, 1, 1, 1, 0, 1, and 1, 1, 0, 1, and 1, 0, 1, 0, 1, 1, and 1, 1, 0, 1, 1, 0, and 1, 0, 0, 0. 9, 2, 3, 4, 5, 6, 7, 8. Let me double check. All zeros, 1 here, 0, here, and 0, 1, 0, 1, 0, 1. You can see there's a pattern, right? 0, 1, 0, 1, 1, 0, 1, 0, 0, 1, 1, and here, and this here, here. And okay, good. Those are the corresponding code we generated from last time. This corresponding to 0, 0, 0. This corresponding to 0, 0, 1. And remember the last one, in the example, that is 101 for this one. Okay? This is 101. 101 is this one. Okay? 101. This is 101 here. Now, to answer your question, is that can we have two solutions, both which equal to 1? That means we don't know which one to choose. The answer is no. Okay, now let's see what's the reason. I give you this code. What I ask you is, what is the capability for error detection? What is the capability for error detection and the capability for error correction? How to do this? I'll give you a set of code. Ask you, what's the capability? How many errors of this one this code can detect? How many errors of this code can correct? How to do it?
Multiply.
Anyone still remember? You don't review lecture notes, do you? Okay, we need to find the minimum distance. Right? The minimum distance, d minimum, will be equal to, for error detection, which is easier, this one will be equal to t plus 1. Right? For error correction, which is more demanding, and this minimum distance must be equal to
It's 1.
I think it's -1.
looks like you're from another class. Right? Equal to 2t plus 1. Right? This one. So this is the number of digits that we can detect, t. This one, t, here is the number of digits that we can correct. Right? So I want to determine how many error we can detect, how many error we can correct. So that means we need to find the minimum distance, the Hamming distance. The minimum. We have 8 sets over here. How many distances do we have?
Huh?
How many distances between each code? How many distances do we have?
3.
Right? We have this distance here is from here to here. Distance from here to here, right? And distance from here to here. And distance from here to here from all this one. Does that make sense? And we are going to have distance from here to here, here. All this, right? So for example, what's the distance between these two? What's the distance between this and this? What's the distance between this one and this one? So how many distances do we have? You can see the first one has a 7, right? From here to 7. The second one has a 6. 1, 2, 3, 4, 5, 6. The next one has a
56.
okay, but you go back, so you need to divide it by 2. Perfect. Okay, 56 divided by 2, so 28 differences. The distance between me and you is the same as you and me. So 56, you counted twice, so you divide by 2. That make sense? Everybody?
I thought it was 8 times 7.
Yeah, 8 times 7. But 8 times 7 means, okay, this one is to here, but you also count this one to back. You don't need to do that, right? 8 times 7 means you calculate the distance from first one to this, to this, to this. Then once you calculate this one, you don't need to calculate the distance from here to here, because you already know the distance. So you only need to go this. So the total distance is, the first one is 7, the second one is
8.
6, right? You only go down, you don't need to go back because you already know that. Then plus 5, plus all the way to the last one is 1 here. So this add from 1 to 7, so that one will be equals there are total 7 numbers, right? Times okay, 7 plus 1 equals 8, then you need to divide by 2, so that is 28. Very good, okay, 78. 56. Alright, now let's take some examples. What's the distance between here to here? 3. Okay, I ask each body. Alright, now your turn. What's the distance from here to here?
V.
No, V in terms. Okay, tapping. What's the distance from here to here? What is it? Huh? This one is nothing, right? This one, yes. This one, no. This one, no. This one, yes.
3.
Yes, 3. Okay. Corey. Okay. This one to here.
It changes.
This one, yes. You tell me yes or no.
Yes. No. Yes. No. Oh, yes. Yes. No.
How many yes do you have?
4.
4. Okay, so the distance is 4 here. Eh? So do I need to ask each of you, or you already know that?
What are you saying yes and no to?
Means they are different.
Oh, okay.
That is called the Hamming distance. The Hamming distance between any two pair of code is the number of digits that are different. So I said yes means they are different. No, no means they are same. So it's not a distance. So in this case, this one is no because they are the same. So there's no distance between here and here. This one has no distance. This one is a distance because they are different. They are different. They are different. This one same. So there's no difference. So we have 3. Yes means 3 are different. So the distance between this and this is 3. Make sense? So you are going to try this how many times?
28.
28 times. What do we want? Some are 3, some are 4, some maybe I don't know. Okay. What do we want? Once you list all these 28 distances, what do you want? The minimum, not the maximum. Eh? Memorize this? The minimum. You look at the minimum in this 28. Okay, I tell you the result equals 3. You do this. Okay, equals 3. Now tell me, how many errors can this code detect?
7. 2t plus 1. If it's 3, what's t?
T, that's what I'm asking. What is T? That is my question.
Is that 3?
How many errors can this code detect?
2 times t plus 1.
That is correct.
I know.
Your answer is wrong.
What?
That is for correct code, not you. You are wrong. This way.
8 errors.
I mean, I ask you how many errors can this one detect without correction? Do not correct. Try to detect.
How many you can detect that's wrong?
Yeah. You got to just tell me, okay, how many wrongs? I don't know which one is wrong, but I know how many wrongs. What is T?
7. That's all.
I guess 3.
How you get 3? I want to explain 7 first. How you get 7?
Well, 7 because before we added the plus 1 to 8 and divided it by 2, they got our correction. You know what I'm saying?
The only thing when you did, if I ask you a question, ask you determine the capability for the code to detect error or correct error. The only thing you need to know is the minimum distance. Once you find the distance, then you use these two formulas to solve for t. T is the capability.
So 2.
Hello? How many errors can we detect?
You want to solve for t with the two formulas?
2.
Here, right? So if I ask you the capability for detect, you're going to use this formula. We know this one equals what?
3.
3. So what is t? 2. You can detect up to 2 bits per error. You can say, okay, there's no error, okay, that's good. There's 1 error, okay, possible. There are 2 errors, okay, also good. You cannot tell me there are 3 errors.
Alright, so what's the minimum? So how do you get the minimum distance? This is what I'm trying
We already done that.
He's
Well,
saying that's the.
compare-
You have 28 distances, you find the minimum one. That is the minimum
Or you
distance.
just do t plus 1 and you just minus both sides by 1.
So you cannot see, oh, I found 3 errors in your code. Because in that case, you are going to have a lot of solutions. So that is not possible. Because the capability for this one can only for you to detect 2 bits of error. If you say, I found 2-bit error, okay, I believe you. If you say 3 or 4, doesn't make sense. Because this code does not have that capability.
Alright, what would I use this code for?
For communication. That's a digital communication. Alright, so next one we ask, what is the capability for error correction? That means I give you the code, if there are errors, you automatically correct by yourself. You don't ask me. You have the capability to correct it by yourself at the receiver.
1.
Okay, now it's good. Everybody see that? 1. How you get 1? 2t plus 1 equal to
3.
3, so t equals 1. Now solve your question, right? You can only correct 1 bit of error. And you can. That means your error can be, in our example, it is like this, 0, 0, 1, 0, 0, 0. That means, okay, you know the error is here, I can change this. But if you said, there's not a solution like this, then now you need to do, which one is correct? Then it means you cannot do it. Right? And 1 is within the capability for this one. That means you cannot have this kind of solution. If you have this kind of solution, then you cannot correct. Because this one possible, this one possible. You don't know which one is correct. But actually for this code, yes, you can. You can make a decision which one is wrong. You can correct it. So there will be no way you have this kind of solutions. That make sense? Any question on this? So now, how many percent? What's the percentage?
65.
55.
65.
Oh, 65. Last time I remember it's 75.
Yeah, it went down.
Right? Anyone else? You need to have 90% and more, alright? Otherwise, you come back next time, okay? So, any questions? I said, you close your eyes. You do this in your head. Can you do it? Yes or no? Can you do it?
Yep. With some notes.
Right. Exactly. You just said close your eyes and do it. That means what I was looking at.
Nah, I can't do it like that.
Can't do it with no
Nah,
paper.
I can't do it like that.
Now, if you cannot do it, you look at this again. Step 1, step 2, step 3. Right? Now you can do this. If you open your eyes, you can do this, right?
Yeah.
Now close your eyes, try again. That is how we start. Right? In the test, you don't have all this. You need to do by yourself. But you find a job to work, no one tell you how to do this. You need to do by yourself.
It's gonna be in my pocket.
Does it make sense? So everybody can do this?
Didn't fall.
Yes or no?
Yes, sir.
Okay, now everybody get a piece of paper and close everything nose. Alright, let's have
Wait
a
a
quiz.
minute, wait a minute, man. Don't erase it yet.
Hold up now, big.
RHT.
Oh,
That's equal RHT. Yeah, just don't erase this. Yeah, that's all I need.
Still so nice. Give you put here, alright? This one, if you do the final, this one maybe put in your cheat sheet, right? if you
Yeah.
like.
Yeah.
We still use this one here, right? The generated matrix is here.
Okay.
Right? I'll make this clear. Huh?
At which quiz number this is?
Alright, that is your receipt. What I want is what is the code.
Okay.
As easy as this, but you need to do step by step. Right? You cannot just give me an answer, get an answer that's nothing. We still use this generated matrix. You need two pieces of information. The generated matrix, knowing both for both the transmitter and the receiver, and also the code, the something you receive. And you need to determine if your receive is correct or not. If it's not correct, then you need to change.
This extra credit.
That is a quiz.
Oh, this right here quiz?
Yes, that is a quiz.
Oh yeah, you right on time.
Because I know some of you need some extra bonus point, right? For you to pass the test. So that I'll give you a chance. Write clearly step by step. 1, 2, 3. Don't guess. Give me every reason. I want to make sure you understand this. If you don't understand, I cannot blame you, but you need to spend an extra 6 hours each week to study this. That is the requirement, right? This is a 2-hour class, so you need to spend another 3 times 6 hours each week on this. I believe if you really spend 6 hours on this, you are definitely 100% correct. The code is here, because I want it easy to grade. I just use my here. Okay, so I can give you anything, but I want you to use this one. All right, everybody here. All right? This one. Right?
Messed my code up.
Who are you?
You just messed me up, so.
And that, because there are a lot of writings here, I make it easier, okay? So we don't need this, and we don't need this. Okay, that's the only thing, all the things you need. You should write everything like this in your cheat sheet. Do I change it? I change. I change. Huh? I change my question. Okay, the received is 001010. Okay.
Okay.
Everybody check. The R equals 001010. How you get the P and I? I is identity. 1 is on the diagonal, all 0 is on the diagonal. P is here. This is I, this is P.
So the odds is like a given, like pretty much.
I is 1, is identity. Identity means 1. I is 1, 1, 1, 1. All 1 is on the diagonal and all others are 0. That is called I.
Right.
Identity matrix.
Right. And the P's is.
P is this. This is the generated matrix. Generated matrix is in this form. The first left part is I. The second part is the P. That is the P. Make sense?
I think I'm getting it. Hold on, let me see something. Hold on real quick. Oh, which guy?
The way you said it, like the way
Are you sure this is good? You need to make sure step by step everything is good. Then otherwise you saw all this wrong, right?
Yeah.
Are you sure this is good?
With this right here,
Mm-hmm.
how many times did it go?
My point is, if this is wrong, then you
This
make
can't
it,
work.
then you saw correctly that definitely wrong, right?
Okay.
So you make sure the first step is correct, right? What are you?
This one.
What's the step 1?
Step one. The NPR.
So what they are doing now?
Trying to find my I and my P.
Okay, what is I? Okay.
Oh, I copied it wrong.
Okay, yeah, that's good.
Okay. And then I got my E's for each one.
You are solving E right now. You done the first one? What's the step 1? You need to know where you are.
Alright, so I think.
You are still on the step 1. Now you try to solve step 2. Have you done step one? What's the step one? You
I
need
gotta get all the ones, get all the.
step one, you need to find the S. Do you have your S? Not yet. Then how can you solve the second step? Because in the second step, you need the result from the first step.
Alright, so, how do I get my? I know what is R times T.
Okay? Do you know R? I'll give you, right? So now next one, you need to find HT. What is HT?
There's P over R.
P top on. So where is the P?
Right, there's P. And on top side.
Okay, then you know it. Then you do it. You find you solve. You
So
calculate
I'm
S.
lining up, so I'm lining up like this, right? And
That is the P on the top.
then,
Yes. So what is it?
that is it.
That is S.
Yeah, this is.
I believe that is HT.
Oh, HT, okay, so then multiply by R.
No, R multiplied it, not multiply R. They are different. A times B is different than B times A in matrix. So R times HT. Not this one times R. Okay?
Alright, so we're gonna do R. And multiply each to I see no difference.
No, you calculate R times HT. What is R times HT? What is it?
It's gonna be 3 digits.
Then what is it? We need to be very clear what we are doing. So what, you use R times HT. What is it? What you are doing? You get the result. 3 digits. What is it? You know, I know. Okay, what is that 3 digits? Suppose you already get that. What is that number? What is that? S. Okay, now you need to find the S. Then you go to the second step, right? Okay. You're good. P on the top, I on the bottom. You are in the right, wrong, right? That's right. Okay, good. Then to the next. You get it? So you can go. Okay, good. Okay, that's the line. This one. Okay, good.
Like, with the way that you got your code, like right
Where's your
here.
S? Okay. This now, this
Yeah,
one
I
is
had
good.
wrote this one wrong.
Yeah. Okay, so now this is good.
But either one of these could be one. You know what I'm saying? Either one of them.
Yeah.
Yeah, but so how you know which one to
Each
choose?
one can be.
Like the way the code is 4 or 5. Either one could be one.
Okay,
Like
now the question is, that means there's some mistake here, because you cannot have this dilemma. You must have a unique. You cannot say, oh, this one. No, I already answered your question, right? Because the capability for this code is you can determine one unique. Now you cannot determine, that means something wrong with your equation or something. So you need to double check your equation. Your equation is.
oh yeah, when I changed it, it probably changed my
Yeah,
equation.
right?
Yeah.
Because you cannot have this, oh, I don't know which one is right. That means something wrong.
Okay, I got you. The second one.
Okay, everything's good. That is only the first step one. It's then we go to step 2 and step 3. So far, step 1. How you get that? You want to how do you do it?
On this code right here.
No, that's not. Look at this one. Look at the step 2. S, you already know, right? Equals R times HT. Sorry, equals E times HT. So you do E times HT. Then you solve those equations. What is E? E means E1, E2, E3, all the way to E6. And times HT. What is HT? You know that. That is HT. Then you do it and make this
So I go sideways, I go equal.
sideways. Why you want sideways? The first time you use sideways, You write your name, write it.
Alright, so I got my finance ready, right?
Do you have homework to do today?
Hey, wow.
Huh? Yes or no? You decide. You do? Okay. Okay, some homework.
Which homework we got to do today? Which homework?
Homework is number what? 7. Number 7. Number 7.
Oh, I think I already did that. You had messed us up when you changed that number.
You just change
You know what I'm talking about?
Yeah. Okay.
What I'm saying is right in there.
Okay. So now you 100% know this, right?
Yeah, that's too
Okay,
easy.
good. Oh, yeah, too easy, right?
Just check it one time.
But you still need to review this after the class. Huh?
That's too easy.
Because in the final, you are going to be nervous. You totally, forget everything.
Yeah, you're gonna try to make it hard.
Almost the same. The different numbers. You need to know how to do this.
That is one way.
This one, that is that. Can you multiply it? Oh, okay. So look, this one equal to first row times the first column, then will be so that's called 1. That's 1. Right? So let's see, 0 and 1, nothing. This is 1, right? And this one is nothing. This is the 1 here. We need only this and this is nothing here, right? So we need only this and this. This is 1, right? Now the second one, the second number is still the first row, the second number, right?
I just know I got the same answer. I just
column,
have the more.
0, 0, you don't care this two, right?
Pretty sure what it is.
Okay, so this one, and this one is nothing, right? And this one, yes, we need to do that. This one nothing, only this plus this, right? So it's still 0. And this last one, same thing, we need only this and this. So this is 0, this is 0, this is 1, so we need this. And this one is 0, so we need here. This is 1 here, so we need this. And this one is nothing, we don't need, so the 0 plus 0, so we need 0. Right? But if you want to add, the next time, the step 2 is you find this S, which is equal to this equals E, which means E1, E2, E3, E4, E5, E6. It's very similar to this. And multiply by the same thing. All this is the same, right? And you calculate and use the same method. So this one times this equals E1, right? And second one times nothing, E3, okay, so we need plus E3, right? And plus E4. So that is the first number, that's it, because you don't need this. This one here. Then the second number is this times the second, this times the second column, right? So you need only E2, E3, and E5. So E2, E3, and E5. And the last one is only E1, E2, and E6. E1, E2, E6. So that's it, right? So that is the symbol. And we know the symbol is this. So that means this part equals 1. This one will equal 0. And this one will be also equal to 0. So you need to solve these 3 equations. Find what is E1, what is E2, what is all the way to E6. Find this one. First one you check, how about all this equal to 0?
So he already equal.
This works. All E1, E2, all this equals 0, because that is the minimum weight. E1, E2, all this equals 0. Can we add this 3 equals 1? No, because all this equals 0. So this one, all equals 0 won't work. Now how about try this one? E2 equals E3, E4, E5. All others equals 0. Only the first one equals 1. This is good, right? This one is good. This one is good, right? Because there's no E1, so that's 0, 0, 0. How about this one? E1 here. So is this one equals 0? This one equals 0, this one equals 0, but we said this one equals 1. So is this one good? No, so this one is not 1. So we need to make this one equals 0, and we try this one as 1. So is this good? This one is not good, right? Because 0, 0, 0, we cannot equals 1. This one, no. So how about this one? Then you try this, you finally find the solution. So that's in the second step. The next step is you add your error to the receiver, and that is your code. Right?
I'm stuck on the second part.
Okay, so this is good. Huh? This is good. Yeah. So if you get this by yourself, then this is good. Did you get this by yourself? Okay, then that's good.
That's it?
Yeah, this is F. This is step 1.
Okay.
Then you need to do the second step, step 2. Step 2, we know this one. Second is the S equals E to the HT, right? Right. So we know this one. You already get it from here.
Correct.
So that's done. And E is we assume E1, E2, E3, and E4, E5, and E6, right? And times HT. What is HT? It's still the same thing as
Is that how you write it?
this is your HT, right?
Yeah.
Still the same thing.
That's
So you still need to use this one, but not this. If you can do this, then you can do this, right? Yeah, so this one, look. This times the first one here. This times this.
Also, it'll be this time, this time,
No, this one, this line times the first column up to here. Right?
Okay.
So that means E1 times 1, so that is E1. Okay, times all this HT, right? So equals, so we again have 3 numbers. Right? Because you have 3 numbers here.
Yeah, that's
So,
3 numbers.
okay, so the first number is E1 times 1, which is E1. Right?
I'm confused on the E1 part.
This row
Yeah.
times this column.
I understand it, but
So-
I'm saying where you get like,
E1 times 1 plus E2 times 0 plus E3 times 0 plus E4 times 1 plus E5 times 0 plus E6 times 0.
but wouldn't that be H? Like these numbers right here?
This is H. This matrix is H.
Yeah. So what is E1?
E1 we want to find out. You don't know. E1 is the error. It's the first error. So we want to find the E1, E2, we need to calculate the E4, E5, E6. This one multiplied by 1, 0, 1, 0,
Yeah, I get that
1.
part.
Okay, so now you just calculate this times this. First row times first column. First row times second column. First row times the third column. You get 3 numbers.
But I'm just stuck.
3 with the E1, E2. We don't know that.
So check this out, this is my,
Can't remember.
But what is?
this will be my
where-
E right here, right?
Wait. What?
Where the E numbers come from?
E is the error. We don't know. We just assume it is
So what
E1.
I'm asking is how would I set it up beside writing like this? Like what numbers would I put against the matrix?
You don't have number. That is unknown.
So
You just
numbers.
E1.
He's saying, all right, this E1 value, this E2 value, E3 value, so essentially there ain't no E1. It's so essentially E2, so you just write E1 here, and then you're gonna write E4 there, then your first number.
We
Zero.
you know
No,
how
no,
to
no,
multiply two matrix.
So I got
right?
one check.
So this one times this means the
That's
first
the same thing
number
here.
times this plus the second number times
Difference
this
there.
plus this number times this,
And that was-
this times this, this times this, this times this. All this 6
Because
add
I
up
got-
together
I got the
to us
same.
the
Oh,
first.
you did the second line.
Okay.
Yeah.
So now the first number is E1
That's what I
times
was.
1,
Okay.
which is E1.
Yeah, yeah,
E1 times 1 is E1. And the second is
Okay, so
equal,
I was thinking,
times
I was
zero,
thinking of doing
I got
it.
the same thing.
Right?
I'm pretty
And
sure
add
it's the same example.
E3 times
So
zero,
what are you doing is
again.
finding the differences and then adding them.
and next
Yeah,
E4
you're
times
multiplying
1,
and
so
then
we need to have this E4,
Same
right?
thing with number 2.
And the next one will be E5
Yeah, yeah. I
times
agree.
nothing here, and E6
Appreciate it.
times nothing here.
It's just like the example we did.
But I believe your matrix is wrong. Matrix, this
I
one
just
is
wrote
not,
the same
this
C
one
code
you
for
copy
the same one here.
101, 110, that is not one.
So I had
So look this one, this is
101,
P.
011.
You copy the P wrong.
That's what he did.
P is 1101011.
Okay.
Right?
Well, in the end, you're
You
supposed
copy
to.
the P wrong. This is P, it is a look at the P. P, this is
That is,
when you got P wrong. This one is wrong. This P is wrong.
so how do I get that?
P is generate matrix. Your P is wrong. Look at our row.
That's
Very
divided by
good.
HT.
So,
This is P.
Oh, yeah, that's all three, yeah.
is this right?
That's
So,
all.
all your are.
Yeah, that's what I did.
Yeah, right there. So, yeah, I know how to do it. Oh, I'm looking, you want, it's literally.
Yeah, so you write that.
I would do four down. With the index, four, that's one. So that's E2, that's E3, but that's one, that's one. But yeah, that'll be that's go down to the next one. E2.
One, zero comes nothing.
Go down.
So we gotta do it.
So the next one.
This one.
One, two.
One, zero.
I didn't even know. I'm over here like. Okay.
I did.
So it'd be another 1 by 6.
Because
It's so confusing.
Okay. Like this is
Well,
right.
that make it all
That's
zero.
right. It's just
Make it all zero.
like.
Because it was.
Oh, okay. I got it.
Look, on here.
I'm only
R
right.
is very long.
I don't know. I'm not that far yet.
This one
Trying to get this.
0 times 1, nothing. 0 times 1, okay, times 0, nothing. This one here, 1. This one is nothing. This one is 0. This one is 0. So we cut down 1, 1. So that's what the first one is 1. Not 0. This one times 1 equals 1. This one times this.
Right, but for.
I didn't hold mine very good.
This one times this one. 1. Okay, 1, right? This one nothing times something.
Yeah.
Okay, right?
I wrote the
This
same.
one is 1, but this one is 0, another 0. This one 0
I
is
just wrote
0.
the same
Right? So
response.
you have only 1.
Okay, then I do the same.
You do the same thing this, multiply this.
That's what I'm.
The fine E is
Just
really.
as you're not, yeah, you're doing the same thing on this part.
Okay.
Y'all want it to be 1, then 0,
I think they're both one and the same.
and then 0.
Then for C, all you do is
Eh?
add plus E.
Right.
Okay, 9:30. Everybody, put your name and your ID there. That's it.
I'm
I
not.
don't know about you.
No.
No, I'm almost.
You still want to do this? I'll give you, let me see. 11, my class is from 9 to 11:15. Give me back before 11:30. That's the deadline. Yes. 11:30. Good? Because I will be in office 11:20. Okay, I only wait for 10 minutes. 11:30, then you get nothing. Okay, after that.
Halfway there.
As long as you know what the formula stands for.